Hello everyone, welcome to my channel Hypermesh Basic to Advanced. To give a background about my channel, I create videos related to FEA and Hypermesh. So if you are interested in FEA, don't forget to subscribe this channel and follow my website. The link to the website will be in the description. Okay, so coming back to the video, the topic for today is impact analysis. So first of all, what is impact analysis? So impact by definition is when two bodies come in contact with each other and one body is moving while the other is stationary, and the body which comes in contact with the other comes with a high force or velocity. Okay, so in this what happens is one of the bodies is more rigid than the other, and therefore the body which is less rigid sustains some damages. So in impact analysis, that's what we are going to see. We're going to see how the body which is less rigid than the other behaves when it comes in sudden contact with the more rigid body, right? So if you are following my channel, if you have seen my previous videos, one of my previous videos was on crash analysis. So crash analysis was also around a similar topic. So what is the difference between crash analysis and impact analysis basically? So in crash analysis, what we had done is we had made the rigid bodies stationary, right? And the subject, which was the softer body, which was less rigid, was moving, right? Was in motion. Whereas in case of impact analysis, the rigid body is in motion and the less rigid body is stationary, right? So that's the only difference here, fine. And apart from that, there are certain other differences which we'll see next, right? So then, where are these, like, where is this type of analysis used? So impact analysis can be used anywhere, such as automotive industries, aero industry, and this arms and armaments, right? You can use it to check the safety of the cars in case of a sudden collision from sideways, rearways, right? And any air collision, if suppose the aeroplane is flying and a flying object comes and hits it. So how is it? So we can check all of that. Then in case of this tutorial, what I've taken is basically there's a surface, which you can see here. There's a wall surface here, right? So this wall surface is basically, you can consider this as a bulletproof glass, okay, right? A bulletproof material which is impacted by a bullet, as you can see here in the blue color, which is moving at a certain velocity. So this can be used in the arms and armaments industries also, right? Fine. So getting started. So what we all need for this analysis? So I have already, as I told, I already have a surface. I've already created a surface, as you can see in green color. So, and this is a blue color is a bullet which is traveling at a velocity of 5 meters per second, right? So what we are going to see is what happens to this surface or wall when this bullet comes and collides with this wall, right? So the bullet is the rigid element here, and the wall is basically less rigid than the bullet, right? Okay. So I've already meshed the model, as you can see here. So I've used all the 2D elements. I've used the 2D elements for the wall, right, and 2D elements for the bullet also, right? Okay. Now after meshing the model, the very first thing that we do is we assign materials and properties to the components. Fine. So what I've already done is I have created two materials, if you can see here, right? So I'll just expand this and I'll just drag this up. And if you can see here, there's a bullet material here, right? This is the material for the bullet. If I click here, you can see the details here. So I've taken these values for some random material. If you want, you can take any material of your choice and you can test it, right? So these are the values for the bullet material. the rho, e, nu, sigma, and values. Okay, fine. If you want to see these values in detail, you can just check them out on my website, right, in the blog post. The link to which will be in the description. Fine. And this is the wall material. So this is the wall material, right? The values for this also you can check it out in my blog post. Link is in the description again. Fine. So this is what we have created. So we have the mesh model. We created material for both the bullet and the wall, right? Next, we have to create the property for the components. Fine. So I've already created properties as usual. So you can see properties here. So one is the bullet property, right? And if you can see here, it's V1 shell elements. Both are 2D elements, right? So both are shell elements. So these are the value used. Okay. So you can again see these values in my blog post, and you can just follow along if you want to follow the tutorial. You can just see the values and copy the values and fill it and follow along this tutorial from my website. Fine. And this is the wall property, right? So this is how both are there. I've already created the materials properties and the model is meshed. Fine. So now comes the next part. So model is there. We have created assigned materials and properties, right? So next what we will do. So as I told before that in impact analysis, what happens? One object is moving, which is the rigid object, and the less rigid object is stationary, right? So we have to assign some motion to this bullet, right? Which is the rigid body in this case. So what we'll do, we'll assign a initial velocity to this bullet of 5 meter per second. Fine. So we can do that by going to BCs here, as you can see here. If you can see, yeah, BCs. Then we can just, we have to go to tools, right? So we can go to tools here, right? So then we can go to boundary conditions manager here. If you can see, BCs manager, and we'll just click on that. Fine. And here you can see all the boundary conditions that are there. I've already created a velocity load collector, so it's already showing here. You can just right click on this and we can see what are the values in that. Fine. So I've named it velocity, right? I've assigned it to the bullet component and I've given a velocity of minus 5,000 in the negative z direction, if you can see here, right? So why is this minus 5,000? It's basically because velocity, the unit of velocity in Hypermesh is in millimeter per second, right? And 5 meter per second, so it will go to 5,000 millimeter per second. Fine. So this is how you create the velocity and you assign it. Fine. So if we just want to review it, just review how's the velocity looking. So if you can see here, the velocity is pointing towards the negative z direction, right? Okay. Next, so we have assigned the velocity to the bullet, right? So then I've also told that the wall will be stationary, right? So we have to constrain this wall, right? So I have constrained this two faces. You can constrain all the faces if you want. It's not a problem. Fine. So what I've done is I've constrained all the degrees of freedom of this end nodes, right? So it doesn't move. So as you can see here, 1, 2, 3, 4, 5, 6, all the degrees of freedom are constrained. That again you can create from boundary conditions manager, or you can just go to okay, it's not here. You can just create from the boundary conditions manager, right? So what we have done till now is we have meshed the model, we have assigned the materials and properties, and we have constrained the wall, and we have assigned velocity to the bullet, right? There is one more thing which we can do is, suppose we only want the translation motion in the bullet, right? So it should only move along the z direction, not along any other direction. So what we can do is, just to be sure, we can constrain its movement along other directions, right? For that I've created one load collector already. You can see here it's named constraint. You can see here what I've done is I've constrained the other degrees of freedom. Translation in x and y, translation in z is free, and rotation along all axes I've constrained. Fine. So these all we can do. You can just, if you want, you can just not constrain these, and you can check if there's any difference. It's just up to you. You can just experiment with this, right? Okay. So mesh model is there. We have the materials and properties. We have created the load collectors, boundary conditions. In fact, right? So next, what we will do? Next, we have to create the contacts, right? If you can see here, there's a contact created. So what will be this contact? So when these two objects bodies come, collide, impact, so there will be one contact which has to be defined for them to collide, right? So as if you can see here, I've already created the contact with the name contact. And yeah, so the card image for this I've used is type 7, which is the same as what we have used in the crash analysis, if you remember, right? So I'll be making a detailed post on this card images for this, right, contacts. So that will come in some later videos. Or I'll surely post it in my website, my blogging website. You can check it out there, right? So these are the values for the contacts. So you can just check it out on my website, these values, and you can just follow along. Fine. So now what we have is basically we have the mesh model with materials, properties, boundary conditions, and contacts, right? So this all was same until crash analysis, right? Crash analysis also had all of these collectors, right? So after this, there will be one extra collector which we have to create, that is the failure criteria. Okay, so what is the failure criteria? So what is basically happening here is when the rigid body is going to collide with the less rigid body, the less rigid body might fail, right? So we are going to define a failure criteria in this case, like how and when it should fail, right? So here in failure criteria, so the less rigid body is your wall surface, right? So the material assigned here will be the wall material, okay? And these are some values which I've selected. You can just assign some other values and check like what are the difference in the results, okay? So these values also you can get it from my blog post. Link will be in the description, right? So we have defined the failure criteria also with the mesh model with properties, materials, contacts, and boundary conditions, right? So okay, one more thing which I forgot to tell. I have used the rigid elements here, right? If you can see, I have used rigid elements to assign the velocity, right? So if you want, you can assign the velocity directly to the bullet component also. But I have used a rigid element just in case. Fine. So we are almost there, right? So everything is ready. So we can just set up our analysis engine, right? So before that, we have to just create one more thing here. Is we have to create some output blocks, like what outputs we want. Okay. So the output, I've created two output blocks here. One is component output, right? Here I've selected these two components, the bullet and the wall component, right? And the number of variables will be one. Fine. Next is the contact output. So in that I have selected the contact. It's under groups, right? So selected the contact here. The number of variables here also will be one. Fine. So everything is done now. So next we have to give the parameters for the engine, right? So that also I've already given. If you can see in the cards here, right? Expand this. Yes. Engine animation duration, right? So engine animation dt. So here I have given the frequency as 5 into 10 to the power minus 5, right? You can use some other value also, but it's recommended that you to use in this value only for now. Okay, then engine animation elements, what all we are going to see. So we are going to extract energy, PSP, all mices and R plus, right? You can choose others also if you want. Fine. Then engine monitoring, I've kept it on. Then engine run, how long it should run. Okay, so the T stop I have set as 0.005. Fine. Then engine T file I have again used time frequency as 510 to the power minus 5. Fine. So basically, this is how we set up our setup for impact analysis. So next, what we are going to do, we have done everything. So after this, we can go to just analysis here, right? And we can go to Radioss if you can see. Okay, by the way, if you don't know, we are not using OptiStruct here, we are using Radioss. Okay, so basically OptiStruct is also a solver which comes with Hypermesh, right? As a package of Altair. But we are going to use Radioss here as this can be a non-linear problem, right? So under analysis, we'll go to Radioss, right? You can see a Radioss. We'll just click on that, and we have to click on it. Yeah. So here we have to just save the file, right? So here we'll export options will be all, run options will be analysis. That's the name of the file. Okay, options more than thread 6, right? Then we'll click on Radioss, right? So what will happen is after you click on Radioss, two files will be generated, right? So one will be an engine file and one will be a startup file. So this two files name will be 0000 and one will be 0001, right? So these two files will be used to run the analysis in the Radioss engine. Okay. So next we'll just go to the Radioss engine starter, right? Here we'll select the file and run the engine. So as you can see here, this is the Radioss engine starter or dialog box, whatever you can say. And here we have to select the file which we want to run. So the input file will be .rat format, right? Radioss. And as you can see here, this is the starter file, 0004, 4 zeros, right? So it's 4 zeros, right? So we have to select the file and then we can just click on run and it will run, right? So I'll just click on run and show you how it goes. Okay, so I'll click on run. So if you can see here, when you click run, dialog box opens like this, and you can see here, this is how it starts. So this is basically the engine starting. Okay, now it goes on running, and here you can see the details, elapsed time, and what has happened. Measure file. Okay, the time will be shown here, and at end you can see if it ran successfully or not. Fine. So it's written here normal termination. That means there was no problem while running this job in the engine. Fine. So next we can go and see the results directly. Okay. So let's go and see the results. So the results, the hyperview. So this is hyperview. Just analyze the results. Okay. So this is the bullet and this is the surface here. You can see. So what we do is basically select the displacement here. Okay. Just select components displayed. Okay. So the displacement is applied. So now the time is 0, right? The time 0, 0, everything is like in initial state. So we can just go to this animation, like animation controls here, and just click on run, and we'll see how like the bullet goes and hits the one and what happens. So we just click it and it's going. If you can see, its color is changing and it's going. And if you can see that the hole in the wall, right? So when it goes and hits the wall, it creates a hole. You can see it's coming out from here, right? Okay. So basically, this is what is happening. So if you can see here, these are the values of the displacement, right? Okay. So one more thing we can do is just check out the stresses. That's the most like that's the primary thing that we check out. Right? So we can just we have applied it and just click yes. Then you can see just here the maximum on the stresses from 1 to 10 to the power 3 and just see how the surface is behaving. Okay, you see here right. So if you want to just see any static frame, you can just go to the drop down here and select that time. To the static frame at that time, right? So you can see the frame has changed. If you go here, see it's a bit back. If you go more up, see it's very back, right? You can just go to any static frame and you can see how it's there, right? You see the bullet has entered the wall here. It's almost broken through the wall. Okay. So basically, this is how like we observe the effect of impact on the body, right? So this was a very basic tutorial for this impact analysis, right? You can just experiment with multiple surfaces, multiple rigid bodies, right? And you can just see the results. You can even change the material and properties, and you can see the results. You can change the velocity parameters. Okay. So I hope you like this video. So Uh, if you like this video, please like, share, and subscribe. And don't forget to follow my blog post and my Facebook and Instagram. Thank you.